In this lesson, we're going to be talking about relations and functions. We've already started talking a little bit about functions and function rules, but now we're going to go a little bit more in depth. So we're going to start with some important vocabulary that's important for this lesson. The first thing is the word domain. The domain of a function is all of the x values. So anytime I say, what is the domain, those are all of the x values. And the range will be the corresponding y values. We're going to be looking at this specific notation today called function notation. And basically what it's saying is that a notation where f of x represents y in a given equation. So in the last section with graphing function rules, we looked at functions that looked like y equals 3x plus 5. But now it's going to look like f of x equals 3x plus 5. And what I said there was f of x, so f of x. That's what that f with a parentheses x means. So basically what that means is that f of x is the exact same thing as y. They mean the exact same thing. Okay, we're also going to be talking about relations. So basically what a relation is it's a pairing of numbers in one set called the domain with a number in another set called the range. And there are 4 different types of relations, and we're going to talk about all 4 of those today. And then the word function, well, it's a special type of relation in which each value in the domain, those x values, is paired with exactly one value in the range, which is that y value. So we're going to take a look at some relations and determine if they are functions today. Okay, let's go ahead and do a little bit first with function notation. So sometimes you're asked to find f of 2 for the function, and they'll give you a function. So you'll see that the function that I'm given here is f of x equals negative x squared minus 2x plus 4. This happens to be a quadratic function, and what we want to do is we want to find f of negative 2. So here's how you do that. I'm going to say f of negative 2 is equal to, now everywhere that I see an x, I am going to substitute the number negative 2. Because you can see that in my f of negative 2, there's a 2 in for the x, similar to this equation over here. So here's what I'm going to do. I'm going to go negative, and then I'm going to go ahead and substitute parenthesis negative 2 squared minus 2 times negative 2. Again, I'm going to put a negative 2 in for x, and then I'm going to add 4. Okay. Let's go ahead and simplify this now. F of negative 2 is going to be equal to, be very careful here, remember exponents comes before multiplication. So I'm going to say negative 2 squared, which is going to be 4, times the negative out front. So this number here is going to be negative 4. And I'm going to continue on, but I'm going to go ahead and simplify as I go down. Negative 2 times negative 2 is going to be a positive 4. And then I have a 4 tacked on to the end. So you can see here that my negative 4 and 4, they basically cancel each other out, and which means f of negative 2 is going to be equal to 4. And that is my answer. F of negative 2 is equal to 4. Okay, now we're going to use that same type of concept here. It says determine the range given the domain. So I'm given a new function rule here in function notation, and they give me the domain values. If you remember, my domain values are all of my x values, and what they want me to determine are all of my y values. So here's what I'm going to do. For each, I'm going to have to do this 3 times for each of the domain values that they give me. I'm going to start over here, and I'm going to say f of negative 2. I'm going to start with that domain value of negative 2. That's my x value. And I'm going to set it equal to 3. I'm going to substitute negative 2 in for my x, and I'm going to add 4. All right, if I simplify that down, that's going to be negative 6 plus 4, and it's going to equal down to negative 2. You can see that I put my equal signs like this. That's fine, as long as your ending answer says f of negative 2 is equal to negative 2. All right, that is going to be one of my range values. So we'll come back to that in just a second. All right, let's do another one. the second domain value is 0. So f of 0 is equal to 3 times 0 plus 4. All right, let's go ahead and simplify it. 0 plus 4, so that's going to equal 4. So my second range value is going to be f of 0 is equal to 4. And then my last one, let's go ahead and do that. I have f of 5 this time is equal to 3 times 5 plus 4. 15 plus 4, and that's going to give us 19. So my f of 5 this time is going to be 19. So those are going to be my range values. So oftentimes what we do is we put those answers in roster form. So I'm just going to put a little range right here. My range is going to be my little squiggly brackets, and I'm going to say -2, 4, and 19. There they are. That is my range value. So this is going to be my answer to my question. Okay, let's look at something else now. All right, now we're going to start looking at different types of relations. So the first type of relation, like I said, there were 4, is going to be a set of ordered pair. And you can see what a set of ordered pair likes from these 4 examples. It's basically just a bunch of ordered pair together. And in my case, I have 4 in each. Sometimes you can have more than that. You can even have less than that. As long as you have, more than one, that creates a set. So what I want to do here is I first want to go through and I want to determine what is my domain and what is my range. And then I want to determine, is this a function or not? So let's go ahead and look at the first one. My domain values. Again, my domain are all of my x values. So that's going to be 7, 5, -2, and -6. I always like to put my domain values in order, so I'm going to write -6, then -2, then 5, then 7. And my range values are going to be all of my y values. So that's going to be 3, 0, 4, and 2. And again, I like to put those in order as well. So 0, 2, 3, and 4. And you can see that I have them in roster form here. That's usually the most common notation for this. Okay, now I want to know, is this relation, the set of ordered pair, a function? And the way that you determine that is you look at your x values. Only look at your x values. If your x values repeat in any way, then it does not create a function. And you can see here that my x values are all different, and therefore this is going to create a function. And it's really going to stand out when I show you what it looks like on a coordinate plane. But let's try the next one. Let's go ahead and write my domain value. You can see that I have 6, 4, 6, and 5. Since my 2 6s repeat, I do not need to write it twice. So my domain value is going to be 4, 5, and 6. That's all. I don't need to say 4, 5, 6, 6. Because once I say 6, it's already been accounted for. And then I'm going to choose my y values. You can see them here. 5, 3, and 4, and 8. Those do not repeat at all. So 3, 4, and then 5, and then 8. And like we were saying earlier, we have 6 and we have 6 in my x value position. And therefore, if those repeat whatsoever, you do not have a function. Okay, let's do some more here. Let's look at my domain values. I have -3, 0, 3, and 5. So I'm going to go ahead and write those in here. -3, 0, 3, and 5. And then my range values, I have 7, 12, 14, and 3. I'm going to go ahead and put those in here. And you can see by my x values, I don't have any x values that repeat. Now, I do have a -3 and a 3, but those numbers are not identical. They have to be identical numbers in order to not be a function. So in our case here, this actually is a function. Okay, and then my last one here, my x values are 4, 0, 3, and 1. So I'm going to put those in order, 0, 1, 3, 4. And then I've got my y values, 7, 4, 4, 4, 4. That was too many 4. 7, 4, 4, 4. Since the y values repeat, I don't need to write 4 3 times. I can just say 4 and 7. All right, now, is this a function? Now, again, you can see that my y values repeat. But remember, we're not looking at the y values at all. We're only looking at the x values to determine if it's a function. And since they don't repeat at all, this is an example of a function. All right, that was the first type of relation. Let's look at another type of relation. This type of relation is called a table of values. We've seen this already as we were graphing function rules in the last section. All right, so we have our nice table of values here with our x values and y values, and it makes the domain and range pretty easy because they're just those numbers, 2, -7. Oh, actually, I'm going to put these in order from least to greatest. You don't have to do that, but I kind of like to do it. Just makes it easier to look at. So it looks like I have -7, 2, 5, and 12. That's my domain value. And then my y, my range values are going to be -1, 0, 4, and 7. And I want to know, is this a function or not? I love table of values because all you really need to look at is the first column, the x values. Remember, the y values don't even matter, so I'm just going to kind of cross those off. And if I look at my x values, they do not repeat at all, so therefore this is a function. All right, looking at the next example, let's do my domain here. It looks like I have a -4, 3, and 6 is my domain, and my range is going to be 0, 3, and 7. And if I look at my x values and x values only, I can see that I have a 6 and a 6. And therefore, since they repeat, this is not a function. All right, let's look at some of the bottom tables. All right, my domain in this one, it looks like -9, -3, 4, and 9. And then my range just looks like one number, just looks like 2. That's all. Now, it's okay that my y is repeating. It doesn't matter. I'm only looking at my x values. And you can see that they don't repeat. 9 and -9 are not repeated values, and therefore this is a function. Okay, and the last one. This is an interesting one. My domain, well, just one number. And my range value, well, they look all pretty different. So I'm going to go ahead and write those down. And if you look at your x values, obviously they do repeat. They repeat not only once, but 4 times. So this is definitely not a function. Okay, so we have looked at sets of ordered pairs relations. We looked at table of values, and now we're moving on to the third one. This is kind of a unique one. This is called a mapping. All right, a mapping is very similar to a table of values in my opinion because it has those nice little columns or egg-looking figures, but it works the same way. So I actually signified domain and range for you so you can see that the domain is always on the left and the range is always on the right. And we have some interesting arrows. We have arrows pointing from the domain to the range. This will always be the case. They will never go from the range to the domain. So if we look at our first example here, we want to know, is this a function or not? So if our domain values are 3, 5, -7, and -2, let's look at where each one of those domain values is going. The 3 is going to the 0, the 5 is going to the 8, the -7 is going to the 4, and the -2 is going to -6. Each one of those x values are going to its own distinct range value. And therefore, my domain values are not repeating. They're not going, 3 is not going to 8 and 0. So therefore, this is a function. All right, let's look at the next one. It looks like I have 0 going to -5, but down at the bottom, I also have 10 going to -5. Again, think about this. If I were to write this, I'm just going to write it down here. 0, -5. And then if I were to write this as 10 and -5, you can see that my y's are repeating, but my x's are not. And therefore, this is actually going to be a function in this case. Okay, now let's look at this one because this is the first not function one. Look at my -2. Do you see how my -2 is going to not only -3, but it's also going to 14? If I were to create ordered pairs from this, it would look like this. -2 goes to 14, and -2 goes to, -2 is going to go to -3. Let me write that in here, -3. And if I had that set of ordered pair, you would see that my 2 domain values repeat, and therefore this is not a function. Okay, let's look at the next one here. You can see that all of these values are going to 8, the standalone number. Again, the 8 is okay if it repeats because it's the range value. It's all about the domain values, and each one of those are different. So this is a function. Okay, and the next one, well, let's look at this. it looks like -1 is going to two different places. That is not allowed. That means that -1 is the x-coordinate in -1, 3, and -1, -1. Therefore, this is not a function. And the last one is definitely not a function because look, 4 is going to, oh, I don't know why my numbers aren't there. Let's go ahead and put 2, 0, and 1 there. I apologize for that. But no matter what those numbers were on the range side, it doesn't matter because 4 can't go to 3 different range values. So this is not a function. Okay, this was the third type of relation. Let's go to the last one. Okay, the last type of relation or relationship is a graph. And to determine if a graph is a function, we actually use this thing called a vertical line test. I'm actually going to zoom in a little bit. And a vertical line test, basically what it is it's a visual way to determine if a curve is a graph of a function or not. And a function can only have one output, y, for each unique input, x. So we're going to use this vertical line test. And basically what it is this. If I look at my first graph here, I have the nice function. And the function is the one with the nice arrows. It's this one right here. See how he's connected with arrows? Okay, so that is what I am looking at here. All right, this is how you determine it if it is a function. You need a vertical line. So I'm literally just going to draw a vertical line straight down my page. You want to know how many times does that vertical line cross the function that's given. And you can see here that it only crosses the graph at one point. And therefore, if it only crosses once, it is a function. Okay, let's go ahead and look at another one. Let's look at this one. Let's go ahead and draw a vertical line right on top of my function. This is kind of a tricky one because if we look at it, as it is going down that equation, it is crossing that line in multiple places, and therefore it is not a function. Okay, let's look at this one. I have a circle. Let's go ahead and draw a vertical line. You can see that it is crossing it in two different places, and therefore it is not a function. All right, I'm going to draw another vertical line right on my graph, and I can move that line back and forth, and no matter where I put it, it will always cross it twice. So since it crosses it here and here, this is not a function either. All right, if you remember, this is an absolute value function. Let's say I put the vertical line over here. Do you notice how it only crosses it once? Therefore, this is a function. Even if I put the line over here, it still only crosses it once. All right, another vertical line. It looks like it only crosses it right here. This is a function. Vertical line, crosses it here. Yes, it's a function. Vertical line, crosses it twice. Not a function. Oh, here are some cool ones. All right, let's go ahead and draw a vertical line right here. See what I see? This actually crosses it 4 times. This is definitely not a function. How about this one? This one looks like a function. How about this one? That's twice, not a function. Now this one's kind of unique. What if I put my line right here? That would definitely make it a function, right? But what if I put it right here? What if I put it down right here on my actual y-axis? You can see that it's there. Now, these little open circles here, what they mean is that there's actually no point there. So if I were to put a line right through there, well, then this would be a function because the line would not be crossing 2 points because they are open points. So some tricky ones on there, but that basically is the fourth type of relationship that you can look at to determine if it is a function or not. So I do want to go back for 1 second, and I want to go back to the one right up here because it's kind of a neat one to look at something I was talking about earlier. So I'm going to just go ahead and erase that line there for a second so I can show you. We were talking about the x coordinates. Now let's say that on that line right there, it has a point right there and right there, right? If I were to determine what is that coordinate of that point, I could probably say something like this. -2 and, I don't know, 3 maybe. And I could say -2 and -3. Now, because those lines sit like right on top of each other, or those points sit right on top of each other, they also have the same x value. And if you remember from the first relationship, you can't have that because two x values that are the same, that repeat, are not functions, which is why we said this was not a function. So that's kind of how it corresponds to the actual graph. Now we're going to look at how all three of them correspond and transferring them back and forth to one another. You can do this with any set of relations. And what I did here was I started with a set of ordered pair. You might start with a table of values next time, or a mapping, or a graph, doesn't matter. But I'm going to go ahead and I'm going to take this set of ordered pair and I'm going to put it in a table of values, in a mapping, and in a graph. Okay, so let's go ahead and put it in the table of values because this is the easiest. I have negative 3, 3. 5, 0 is my next coordinate. Negative 2, 4. Negative 6, 2. And 1, 4. Okay, I just transferred it from a set of ordered pair to a table of values. Now, I'm going to go down to the graph. Let's go ahead and graph these points. Negative 3, 3. 5, 0. Negative 2, 4. Negative 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. A little off my graph, that's okay. Negative 6, 2 is right here. Sorry about that little point that I made. There we go. And my last one is 1, 4. Okay. Okay, and then I'm going to move to my mapping. I'm going to go ahead and put my values there. Hopefully they fit here. I'm going to do negative 3, 5, negative 2, negative 6, and 1. And it looks like I have the 4s repeating, so I'm going to say 3, 0, 4, and 2. And I'm going to choose another color actually for my arrows. I'm going to go ahead, negative 3 goes to 3 with an arrow. 5 is going to go to 0 with an arrow. Negative 2 goes to 4 with an arrow. Negative 6 goes to 2 with an arrow, and then 1 goes to 4 with an arrow. So I've just created a mapping using that same relation. Okay, and so now that I'm looking at this, I want to say, is this a function or not? So if we go, I'm going to choose green. If I go back to my set of ordered pair and I look at my x values, you can see that they do not repeat. So it is a function for sure. Now just look at my x values over in my table of values. See how they don't repeat? It's still not a function. Down in my mapping, do you see how none of my x values have that little less than symbol? Yeah, it's also a function. It's always a function no matter which form that you put it in. And if you look at my my graph with my coordinate plane, if I put a line going straight down one of the points, it's only going to go through one of the points. No matter where I put that line, it's only going to go through one of the points, making this a function. Okay, so feel free to go back and review the different types of relations and if they are functions or not functions.